Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So our chapter 4. Okay, let us have a look at our list of examples and tutorial. So these are the things and list out. So you will find that example that we need to cover 4.1, 4.2, 4.4 up until 4.7. Right, and including some additional example using different model coming from another book which is survey as well. So for this additional, you can go to this additional example that been given to you. So you will find that we give you this 3.2, 3.3, 3.4. So these are a few more models that has not been recorded in our textbook, or perhaps it's there, however it does not have value. So this one has value. Alright, motion in two dimension. What makes this topic unique? So you will find that in this topic, acceleration will occur simultaneously in the x and in the y direction. However, acceleration value usually varied in the x and y direction, and hence resultant motion in as well x and y dimension. Right. So according to the book, it's just trying to recall a few concepts. For instance, concept of displacement, that the delta is final minus initial, terms velocity, okay, to remember all quantities belonging to the concept of vector. The tangential value, okay, when you measuring the slope of x, right, where you arrive with the instantaneous velocity, acceleration or average acceleration, instantaneous acceleration and such. Alright, these are the things that you're going to use in the next subtopic. Alright, and remember as well, since now we're going to treat x and y, so we are going to emphasize on the concept that writing, for example, displacement will be in the form of I, J, K, I and J. In this case, I and J. So let's now start. This is an example. So the generic way of writing expression speed velocity is u plus at, right? Now what happened next is, as you can see here, they are separating the x meant for u in this case, and they represent the y. So the same expression was written, so look here, same expression is written, v plus at or u plus at, but the sub are meant for only x for I plus y for j. Let us now look at example 4.1, motion in a plane, where in this example, you will find that acceleration value in the x direction has a value, but there is no given acceleration in the other component. Okay, let's have a look. So a particle moves in the xy plane starting at the origin with an initial velocity. Now, two different values. One is meant for x and the other are meant for y direction. So the particle experiences an acceleration only in the x direction. Only in the x direction. It doesn't say anything in the y. So if it's an exam one, it should be properly mentioned. Okay. So a in the y direction is 0. Now the question. Determine the total velocity vector at any time later. Now the terms any time later, it triggers that we are now substituting the number into expression and leaving it together with t as unknown. Okay. T T akan dikekalkan sebagai unknown. Alright. Remember earlier given, okay, they are now setting it into symbol. So U for X 20, U for Y negative 50, AX 0, AY is 0. Now the generic expression of kinematic, V final U plus AT. Now add up I and J, add them up. But now repeat the same expression, substitute for X and separately do the same for J. Separately do the same for J. So in that sense, start with the X just now. So this is the X. Here goes this number 20 just now. Acceleration is 4. So here it's the 4 just now. So 20 plus 4t. 4t. Leave t as t. An unknown that later to be substituted with any t value. Now do the same for j. This is the general expression. But however, the only difference is acceleration tends to be 0 while u is negative 50. So as you solve, okay, so simplify the expression. This is how it's going to look. 20 plus 4t I dot minus 15j. So let's say that the question asks you, okay, at 1 second after this, what will be the velocity? So you are going to leave the answer in the I direction and also j. Okay. Now let us look at B, where in B is we are going to substitute t value, and according to the question, it's asking you to calculate velocity, means that with the direction, and speed. Since it's asking for speed, meaning that this question is asking you to get the hypotenuse or the resultant of the velocity. This is actually okay to leave your answer in the form of I and J. Likewise just now, so by substituting t equivalent to 5 seconds just now, you will arrive with 20 plus 20, which is 40. So this is velocity, right? While negative 5, 15j. So this is x component, this is y component. Okay, so again, this is velocity because it bear direction in the form of I and j. The direction itself, so as we can see, this is y, negative 15, and the x is 40. So leaving your answer either as negative 21, or if you remember our previous session, our y would be negative 15 meter per second, and here is 40. So our angle 21 is measured over here, 21 degree, below positive x-axis. And in the case that it's negative, because the way it's being read, either clockwise or counterclockwise. Recall that. And finally, asking the speed required you to calculate either the resultant or the hypotenuse. We call it the hypotenuse or resultant. So in this sense, so go back to the concept of trigonometry or hypotenuse as such, and you will arrive with as the answer. So this number now, 43 meter per second, is your speed value. C. Determine the x and y coordinates at any time. At any time was actually to substitute only into expression. Okay, meaning that to get an expression and its position vector at this time. So, in that sense, if you can see here, R is R. So, I'm going to jot it to something that you have seen previously. Delta x ut plus half a t squared. Now this kinematic expression is similar to this. And then as you simplify, the final version becomes x initial plus ut plus half at squared. The same. So it's just that the representation of r is now equivalent to x. So the same. Right now, next what happened is you have to repeat the expression into I and j separately and adding them. And hence, that's how you arrive with as given that the initial position in the x and also y are 0, and then u is 20 for x direction and y direction is negative 15. Finally, a is 4 and a is 0. And simplified, you are arriving with this expression. I meant only expression occurring in the x direction, and this is occurring in the y direction. 4.3 Projectile Motion. Now, projectile motion is whereby object would be moving in a parabolic motion. So, it's nice to know and also to note that we will find that there are two values of acceleration occurred in the motion. In the x direction, there is no acceleration, 0. And the y direction is in free fall. Something to remember and recall as well, that you should note acceleration of a projectile at the topmost point is 0 in the y direction because it's about to turn direction. So this one, okay, it's the y velocity in the y direction is 0, but not in the x direction. X in the direction, since acceleration is 0, so therefore you will find that in the x direction has the same value of v x direction throughout the motion. 4.3 Projectile Motion. So what is a projectile motion? So a curved motion in the air is a projectile motion. Curvature trajectory is parabolic. Yes, a projectile motion. Now, there are two important assumptions to be made in this case, that there are two values of acceleration. Number one occurring in the x direction, number two is in the y direction. In the y direction is the one that you have done earlier, which is free fall. That acceleration is always negative 9.8. While acceleration in the x, because there are no forces occurring in the x direction. No force, ma is 0, a is as well 0. And that is the main idea to be used in here. However, okay, let's look at pitfall here. You will find that the velocity at the topmost of its trajectory is 0 for only y component, but not x. Remember that x has 0 acceleration, and hence there will be a value of v belong in the x direction at the highest point. And therefore, a few tips before we proceed with an examples. By looking at figure 4.9, if let's say an object is launched from the ground at an angle here, at a certain unknown angle, then you have to start with open up to the x component and y component. And in this case, it's stated as in the x component has a velocity, not speed. Velocity meaning that you have to consider the direction. That the direction in this case is a positive value up here to the right. Sorry, the x component is directed to the right, so it's a positive value cos theta, while the y component is also directed upwards. Y component directed upwards, so you will arrive with a positive initial velocity belonging to the y component. So the rest are just expression that you're going to use. Okay, you're going to use. And it's something to look at 4.18. They have simplifying expression. Okay, but bear in mind, you can use an alternative methods to get t here beside having this expression. What is this expression? This expression is a simplified expression, combined expression to get time from here to A. From here to A, right? From here to A. So how did they do that? Okay. What they did is that this is what happened in the y direction. Okay, in the y direction. So you will find that at the location where A occur, at the topmost, highest point, the velocity in the y direction turns to be 0. So here is the V final is 0, like this one. And U is an unknown number that later would be given according to the question. And then when you simplify, the time would be the initial speed times sine theta, which actually already a product of y component divided by 9.8. Alright. So if you are interested to find for the next one, let's say that to get y final equivalent to A, in this case means that maximum height. So you can do modification to the expression and arriving with this one. Alright. Now, what we are going to do after this, we're going to do two techniques. Number one, by substituting directly this expression. So either this or this, according to whichever type of question. That's number one. Number two, we're going to start from scratch. Okay, scratch. How do we arrive with this expression? Now, interesting to note as well. Okay, this is an expression. If let's say that you have extra RAM to remember, yes, you can do so. Okay, so this expression meant to get the time required to get to the highest topmost position. This is the height in the case that the trajectory is symmetry. Like this one. Okay, symmetry. Same level. Right. So at the same time, you can as well use the concept. Okay, this is the derivation to get to what we call as R. What is R? As R is range. R is range. Horizontal position. The whole length from the start up to where it lands onto the ground. So the R distance is the X displacement. Total X displacement in the case of a symmetry. Now, this is an example of how if we vary the angle, provided that the initial velocity is the same. So, we will find that in order to get to the largest displacement of X is belonging at the angle of 45. But this is just to look at. But you would not be asked to memorize it. Now, looking at example 4.2, you will find that this example shows that we're going to do and substitute the expression, the simplified expression, okay, according to the request question. So this is a long jumper, leave the ground at an angle 20 degree above the horizontal and with an initial speed of 11. This 11 is the initial, neither X, neither Y. So it's the resultant. Now, since the resultant, this is just a pure U. Okay. In the case of getting how far in the horizontal direction, it's asking for R. So this is the expression. By substituting, you will be arriving with 7.94. By asking what will be the maximum height, it's quite direct. Use again the expression given earlier. Which one, madam? 4.19. 4.19, this one. substitute, and you will arrive with 0.722. So note that 7.22 is this distance, while 0.722 is the vertical distance. This is the R just now. Okay, he leaves the ground and then landed on the ground. But bear in mind, this expression only valid if it's a symmetry, a projectile that start from the ground and then ended on the ground. Now let us have a look at example 3.3. This is an example that shows technique where we are going to get that expression from scratch. Okay, so the case is a long jumper leave the ground at 20 degrees and the same speed 11 and asking the same thing. How long does it take for him to reach the maximum height? So let's see how it was done. Right, ing. Okay, it's actually ing, but since this is another version of survey that does not make use of the calculus ijk, they are a very simple version where you just put aside the x component and y component. And something to remember from the previous slide, from the previous idea, that acceleration in the y is negative 9.8 meter per second, and x has 0 value. Alright. Now, in terms of the time, you can go and use the kinematic expression and use the version of the free fall. What do you remember then? When it reached the maximum height, the velocity would be 0 at the maximum height. And then this turns out to be 0. This is 11 just now. Angle is now 20. G is now, well, it's together with 9.8. Okay, it's already jotted down as negative. So just a pure 9.8 only. Alright. And our aim is to get the T. So our T now becomes 0.384 second. 0.384 second. Right. Done. So this is actually how we do it. So if the question is asking, find the time B, find the maximum height he reaches. Okay, he reaches. Remember the kinematic. Okay, most of the time we can get all the things, all the unknowns from the free fall technique, in short, from the y component. And hence, look here, this is ut plus half at squared. Ut plus half at squared. Only thing that you note is this is delta y. And remember that it's y final minus 0 as the initial. Why? Because it starts from the ground. He started from the ground. So that's the reason why when they simplify on the left side, it's just left with y final. So this is the y final just now. And u must be in the y direction. So what would be y direction? 11 sine 20. And the t just now, substitute. So it's as if you set a limit. This is the initial, and you substitute the time that he reaches here. And hence, you should be getting h, a y value at this location. So t just now, 0.384 is from the duration from here up to here. Therefore, you will be getting y final at this location. And dia punya limit kat situ. And the solution 0.722 meter, the same solution that you get from the earlier version. Now, how about C? Find the horizontal distance, he jumps. Horizontal distance, he jumps. He is asking for R. This is R. Okay, so aside of the technique that you seen just now, these are the technique. R is actually occurring in the X direction. Since it's occurring in the direction of X, means that you have to use all numbers coming from the X direction. And in this case, you will find the idea of acceleration in the X direction is 0. Hence, X will be the speed in the T direction. U in the X direction. And that's the reason why X is calculated by using component of U in the X direction times the time. Now, something to ponder. T is 0.768 seconds. Why? Now, T max occurred at 0.384 seconds. So, doubling it means that you have a symmetry time from the start at the ground, ending at the other side of the ground. But yeah, so twice of it. So meaning if you substitute T in the Y direction to get height, you get 0 height. But if you substitute T here in the X direction, then you are going to get this X. The whole X that occurred for the time of 0.768 seconds. And for that, you are arriving with 7.94. Now, you don't need to remember the expression from the previous survey, but what you did just now is by matching in the expression of kinematic. And finally, okay, use an alternative method to find the maximum height. The alternative method is by making use, since this is maximum height ni berlaku kat mana? Y ke X? It was Y. So since it's Y, therefore use free fall approach. And in the case of the free fall kinematic expression, so aside of the ut half at squared, you could use the one v squared, u squared, 2a delta y. Okay, right, all the vectors. And then during the maximum height, remember that the v turns out to be 0. Why? Because all these are y component. So Vy is 0. This is what indicated here. Here. So 2g, this is u. So u in the y direction. Notice that it's sign product because this is uy. And then divided by 2g. Okay, 2g. In the case, you find that 0.7 to 2 meter. So the same technique. So altogether now, you have 3 techniques. Now we are going to look at an example where object now make use of half of the symmetry. In that case, let's turn to example 3.2, Standard Explorer. So let's straight away look at the figure. Notice that it's half of the symmetry. Effecting to this, you will find and recall that the U at this location in the Y direction and also in the X direction would not be similar to one another. And in the case here, if you can remember, the U or the instantaneous velocity at the location here is 0. Okay. Why? Look again at this figure, familiar. So partial of it at the location at the highest position, at the highest in this case, position highest here lah. The instantaneous velocity is 0. So in the case of this figure, this plane is supposed to drop a package to stranded hikers. So it's traveling horizontally as in figure. So therefore, d40 is initial speed of the release package. Okay, because the plane traveling at 40, the package is released at that speed, and hence that is our initial speed. However, only for ux, uy would turns out to be 0, and the height would be 100 meter above the ground. Neglect air resistance. Okay, so this is condition for you to use G is negative 9.8. Now, where on the ground it strike, or it's it strike, maknanya dia reach the ground kat mana? So this question is actually asking for X ataupun R. Okay, so now let us look at the question. Alright, this is our X. This is our R of interest. Now, looking at the expression, and if you can recall, the generic way to calculate R is you need U in the X direction, then times the whole duration. In the case of getting 40 into the expression, UX the 40, bear in mind, the time would be measured right from here, point A, to hits the ground, B. So this time interval would be between A and B. Now, time can be measured from the concept of free fall. Free fall by looking only at the y component. By looking only at the y component. And as you can see here, display the expression delta y is ut plus half at squared, where a is negative 9.8. Look at how they substitute dy. Okay, let me jot it down. Y final, y initial. Our final is at B, while our initial is at A. Let's say you can choose any reference. In this scenario, we say that y at the ground is 0. Hence, this is 0. While the initial is up there, above the ground, positive 100. So, by this is our y final. Okay, this is our delta actually. Look here, right? It's arriving with negative 100. Okay, negative 100. This is negative 100. So substitute over here as our delta y. Ut is 0. Why, madam? Remember just now that object is traveling horizontally. So vector of velocity drawn here, overlapping on the x direction. So it has no y component, 0 y component. So since it's 0 y component, same as this concept, dia tak lari pun. At the maximum peak, at the maximum point, uy is 0. U adalah 0. Okay, U is just symbol. Tapi at this moment, it's initial speed of this object. And because of that, the expression is just half gt squared, half gt. So this is 1 over 2 g. Okay, 1 over 2 g t squared. So as you simplify, you will find that t is 4.52. Since u that you substitute is occurring at point A, and y just now, your y final is at B, therefore the time would be in between A and B. So what is the time required for the package to reach the ground? Yes, 4.52. Then substitute into the R, which this number will give you. So the distance 1 meter is here, from here to here. Now, let's look at the second question. B, what are the horizontal and vertical component of the velocity just before it hits the ground? Before, because if it does, then afterwards hit the ground, the velocity turns to be zero lah. It stopped kan? So, we do not want the student to think that the V final is zero. Do not think that it's zero. They just right before it hits the ground. So in that sense, okay, recall again that acceleration in the x direction is zero. So because x has zero acceleration, then we have the v final always the same value. In this case, always 40. Now, why does it substitute zero here? Cos zero. Remember, this is the x just now. This is also the direction of the velocity. So what would be their angle between these two? 0. So cos 0 is 1. How about velocity final? So again, whatever in the y direction, you have to go back to the free fall. In the case of the free fall just now, remember that this is u in the y direction plus at, and our a is negative 9.8. So this is 0. This is it. Negative 9.8 t. So arriving with negative 44.3. The last question. Now upon impact, okay, means that, let's go, angle. Now upon impact, observe that the velocity before it hits the ground. I'm sorry that my figure does not look, it's really overlapping, but you can see that it's making a small angle. And that is the one we want. If I were to draw something like this. Okay. So, okay. This is the angle that we are looking for. This theta. So how do you get this one? By using the component of velocity that we have from B value. Okay. The velocity final, this is Vx, no issue, 40 just now. This is the Vy that we have calculated earlier. So you are arriving with negative 1.111, sorry. And inverse tan, you have 48, negative 48 degree. Okay, negative 48 degree. Just to cross-check the figure. So the reading of the angle is below positive x-axis. Now let us have a look at example 3.4, the range equation. So you will find that this is a situation where projectile is fired from the ground. So from the ground level, so the same level. So if it's the same level, almost similar to the motion of the long jump just now. So an athlete's long jump competition, leaping with initial velocity u0, v0 symbols at an angle of theta naught with the horizontal. Obtain an expression by using this symbol. So we will find that the time taken in the case that he jumps, leaving the ground and then end with the ground, similar with this figure, right? We have 2 times of T max. The time taken would be twice of the T max. And T max, if you remember, expression that perhaps you can recall, or perhaps you can go back with the expression of your own expressions. Okay, so V naught sine theta over G. Okay, so this is R range, branch, and this is the component of X for T and U cos T. So substitute this. Okay, we have this and V and then V. So we have this one. However, okay, something to look upon. Okay, There's one from high school, that cos theta times sin theta is as well equivalent to this one, sin 2 theta, sin 2 theta, right? So since sin 2 theta, then we can simplify it. 2 cos theta sin theta is sin 2 theta. So therefore, we can now simplify it into this expression. Okay, they did mention the identity, that 2 cos theta sin theta is sin 2 theta. So simplifying to one trigonometric function, which is this one. Now let's get back to the book, GVAT. So we have done example 4.2. Quite a number of examples related to this one. And at the same time, we have covered all the examples provided in the additional examples. Ada 3 saja, there are only 3 of them. 1, 2, and 3. So we are not supposed to be covering 4.3. One of it because it involves a lot more of equations. So this is another example where it starts not at the ground level above, but yet with an angle. Okay, let's see how is it. That's quite an arm. Okay, that's quite an arm to show that he can throw at a large speed. Right, a stone is thrown from the top of a building as indicated 45 meter high. The angle of the initial is 30 degree to the horizontal. This is the horizontal, so right above the horizontal, 30 degree. The speed is 20. Now later we need to modify so that it has directions as shown as in the figure. So how long does it take to reach the ground? If it does reach the ground, then we will find that this is our initial position and this is our final position. Okay, and hence the kinematic expression that has time inside it, either v u plus at or delta y is ut plus half a t squared. Either. We are not going to choose this one. Why? Because we do not have v at the location on the ground, which is b. So no. We are going to use this one because we are aware that height is given. If let's say this time around, we are going to consider this as 0, the initial position as 0. Initial position as 0. Okay, this is 0. Hence, our final position would be negative 45. Okay, negative 45, concept of vector. So, notice that our delta y is now negative 45 because final negative 45 minus 0. Final, the b is final minus initial. So, negative 45. Now, the ut, okay, that is the final delta, sorry. Create straight away nampak ni ya. Right, and ut, the ut must be u sin theta. U sin theta, this one, 10. Why? Because we have to open to the nearest x and the nearest y, and we are going to take only the y component. So everything aside from the r or x, we are going to operate in using y component, free fall. And because of that, u sin theta is 10, then t is an unknown, and then plus half, negative 9.8 t squared. So solving, you will arrive with 4.2. Use your calculator for this process. Please use your calculator. So in short, from A to the ground, which is B, required 4.22 seconds. So how long it reached the ground. Now, what will be the speed just before it strike the ground? So, do not put it as 0. No, it's not 0. 0 means it stop. Means that it's already strike the ground. Dah kena ground. Kita nak just before. Just right. Betul-betul dekat dah. And because of that, okay. So, you can now choose the T just now. Remember this expression earlier? Yes. Okay. So, since T that we are going to substitute is 4.22, remember that 4.22 is the time from A up to the ground, B, up to the ground. Therefore, this is the initial location at A, this is at B. And what is this? This is just now positive 10. Why, madam, positive 10? Recall again that the arrow indicated is at an angle above the horizontal. So, our resultant V is vertically upwards. So, positive 10, which is 20 sine 30. And because of that, solve, you are going to get negative 31.3. Okay. So, this is the Y component since the question is asking speed. Speed is the resultant of the two component X and Y that are combined. Kalau the velocity, yes, probable kita nak bagi the two answer, Y component, X component, and then kita kata, okay, we are done. We are not going to combine and get the hypotenuse. Then it's okay. It's okay. Okay? Sebab both are velocity. However, in the case that it's asking for speed, careful. It's asking for resultant or the hypotenuse. In the case of a hypotenuse, remember again the trigo, this expression. Okay, and therefore notice that this is u in the x direction. U in the x direction. What are those? There's one. 20 cos 30 17.3. And this one is the one that you have calculated earlier by using free fall. From free fall. So, arriving with a single data, a single magnitude of 35.8, a combination of the two vector earlier.